End of week 14, we're reviewing test 4. You've got your test today, tomorrow, or Friday. You've got all of these sections to go through, plus the review. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points, bonus points. Wow, big fat grade change right there, just based on your homework. And I mean, I know you figured this out. If you've got 100% on your homework, you're doing so much better on your test because you understand what's on the test. So it works in your favor in so many ways, in 3 distinct ways I can think of. That way, in that you get the 11 points, the way that you understand it so you do better on the test, and it counts 20% of your grade, so you're maxed out that 20%. We may go over a little today because I have the choice of either cramming it down your throat quickly to get it in at 1 hour and 20, or taking my time. So if you need to leave at 9:20, you leave at 9:20 knowing that the recording will pick up the last few problems for you. If we go over, I don't know, I never know. But I don't want to, hurry this because we don't need to. You're not rushing to another class, and if you are, there's the recording. Okay. Let's get started on this. Let me zip out here. Okay, I changed up the review last week. I changed number 6 to a slightly different problem because we'd already done number 6, and I don't want you to be able just to mimic back this one. So I changed this one on the, you've got access to that one on the Google slide, and I'll write it down here for you too. So that'll be a different one. This one we're just going to omit. You won't have one like it. Number 8, we're going to omit. Won't have one like that. Which reminds me, remember your problems are randomly ordered. So you will have a problem that says solve by substitution. And it will look like this, a nonlinear one where you've got an x squared in there. This one you can do. But the one, so you'll have one like this, one similar to this. You'll also have one that is xy equals 6 and x squared plus y squared equals 37. I will completely omit that problem. I can't give you a number on it because they're randomly ordered. So yours might be first, it might be 25th, but I will omit it. You'll get full credit for it. And I don't care if you get it, if you miss it, I will give you the points. If you skip it, I will give you the points. If you do it and get it right, you'll keep the points. So whatever. So it starts solve by substitution, and it's got a linear. Well, that's not even a linear. So it's got an xy equals 6. If you can remember that, I think you'll be able to remember one problem that you get to omit because it's free points, and we remember free points. So that's there. And then I did add 3 problems to the bottom of this to bring it up to 25 points. Okay, let's get going here. We're solving, and when you do it, one of them will say by substitution. This is a good one to say by substitution. What they guide you toward is an easy way to do a problem. So this one will be built for substitution. You can see you've got a y equals right there. Everything else in the problem is over on the right-hand side. So we'll substitute that piece into this problem. We'll get x minus 2 times, oh, there's a y. Put in the y equals negative 8, and then continue on from there. So let me just drag that over to the other page. It's number 1. So we've got x minus 2 times negative 5, x plus 15. Okay, and then you'll just continue on. You'll distribute here. So x plus 10x, then negative 2 times 15. Combine like terms, we've got a 1x and a 10x. So we've got 11x. All of the x's are on the left-hand side. Let's move the numbers to the right-hand side. So x equals 2. So we've got part of our answer. We've got the x piece. In a substitution problem, the easiest way to find the y, you can go back to the originals and plug it in if you want to, but the easiest way is going to be here at the substitution block. So I was told this. I will go ahead and plug in a 2 there. Y equals -5 times 2. So y equals 5. So 2, 5 is the answer. All of these are multiple choice, so you don't have to worry about, what if I forget the parentheses? You won't forget the parentheses. Okay, number 2, we'll say solve by addition or by addition elimination, that kind of thing. So let's look at that. And let me remind you, now's a good time, let me remind you that when you go to take your test, it'll look like this. It'll be available at noon today. It's under Proctorio Test Proctor, and then go to Your Exams Are Here. And the only thing that's new is scratch paper. You must show work on the problems we talked about in the review. So that's what we're talking about right now. The problems that tell you how to solve them by substitution, by add elimination. These will tell you, these either won't give you instructions or they'll say by Gaussian. Go over to where the Gaussian is. Augmented matrix. Yeah, solve the system using matrices. Oh, you're not even looking because you're looking at that. Sorry, I'll get back to it. I looked over at my computer screen because I can always follow what I'm doing, and there's still the instructions for the test, so duh. Okay, so I will talk about that as we go, but because we have 2 or 3 ways of doing each kind of problem, you need to be paying attention to the directions. You won't get credit for the right answer without having the right process. And then, because I'm going to be hunting through your paper a lot, make it easy for me to read your scratch paper. Most of you do that. Most of you, it's so easy. Even those of you who think it's not easy, it's very easy. But those of you who just sort of, put a problem on the bottom side of this one and then the next problem goes on the top of that one, that's a little bit difficult to follow. Okay, let's go back. Okay. Okay, so number 2, we're going to solve by addition. Got x plus 3y equals 1. And 5x plus 2y equals 18. Okay, in order to solve by addition, you need to be able to add the x's up and have them cancel out, or add the y's up. If we do the y's, we're going to have to change them both because 3 and 2, one is not a multiple of the other. So we'd have to multiply the top. We'd have to bring them both up to 6. This will be easier because we'll only have to change the top one. 5 is a multiple of 1. Yes, right there, by substitution, yes. And we did substitute, y equals everything else. So we substituted it in place of y. You're welcome, Clay. So it will say, on your problems, it will say what to do. Okay, so on this problem, we are add eliminating. We'll get rid of the x's. That'll be a one-stepper because 5 is a multiple of 1. So I'm going to make this guy be a -5. So we'll distribute that. -5x minus 15y equals -5. These are the same equations now, just one's a jacked up version of the other, but they're the same equations. 2y equals 18, gone. So -13y equals 13. So y equals -1. So these two cross at something -1. I've got the y. I don't know what the x is. Plug it into either of these two equations or this enlarged equation. That doesn't matter, but just pick one. I'll pick the top one, I think. So x plus 3 times y is a -1. So x minus 3, add 3 to both sides. So x equals 4. So 4, 1 is the answer. That's the only pairing that will work in this equation and this equation. You can test it out. 4 minus 3 equals 1, and then 20 minus 2 equals 18. So it works in both of them. So that means finding the actual answer is not going to be the challenge here if you want to, try them out, plug them in and see what works. You've got to show me the process. Okay, we are not going to do number 3. You're not going to have one like it on the test or the final, so we'll just ditch it. Number 4 says solve. It doesn't tell you how you have to solve it. You can solve it any way you want. If you want to do it Gaussian, go ahead. If you want to do it two sets of, two Keeper equations, I think that's the way I'll solve it, because when we went through this, that's what we were doing. It is totally up to you, though. So let me write this down. Okay, I'm going to work on getting 2 sets of equations in 2 variables. I've got 3 and 3. I want 2 and 2. I think first time out, I'm going to get rid of the x's. X's right out in front, it's easy to see. So I'm going to grab these 2, the top 2. Okay, and I'm going to multiply this equation times -1. That'll cancel out the x's. Negative x minus y minus 5z equals -15. X's are gone. That's what I intended to happen. But also the y's are gone. I didn't intend that to happen. It just did. So we'll have to, change gears a little bit. We've got 5z equals 15. So z equals 3. So I've got one of my answers. There, I've got the z. But what I don't have is a place now to put that z. If I've got one answer, I've got to go after an equation with just 2 variables. And I don't have one of those. I got lucky here and got rid of both 2 variables. That's sort of lucky, unless you don't know what to do next. So we need to keep doing what we were doing in trying to get a Keeper equation. So I've already looked at these 2. Let me go now, and I'm going to look at the first and the third. Doesn't matter which I pick. Just decided to pick those. So let me write those 2 down here. And still doing the same thing. I had killed x's here, so you want to kill x's the second time through also. Trying to get something that still has a z in it so we can plug this z in. So let me scoot everybody over here. And when you do this to show me your work, you don't have to, if you want to put a -1 here and then just put your answer, if you want to skip this piece here where I have taken them and rewritten them and then shown that I'm doing -1, you can skip this. I get it that many of you can just put a -1 right here and scoot over and get this. So you don't have to show every stinking step that I show. 2y minus 3z. X's are gone. Excellent. That's 3y, 7z equals 3. There's a good Keeper equation. And we can use that now. We can plug in the z that we've got to get a y, and then we'll be able to move on up. So let's look at what that'll do it for us. 3y plus 7 times 3 equals 3. So y is -6. And now armed with 2 of the answers, 2 of the variables answered, we can go up and grab any of the 3 equations in 3 variables and plug in the z that we know and the y that we know. I'll just grab the first one. So we've got x plus, let's see, y is a -6, plus 10 times z is a 3. And there are many ways of doing this. I grabbed the first 2. You didn't have to grab the first 2. I'm killing the x's. You don't have to kill the x's. You might have liked what you saw in the z's and decided to multiply the second equation times -2 to kill the z's. It doesn't matter. So the whole process, your whole process might be different from mine, and there's no problem with that. Plus 30 is 30, so x plus 24. So x equals 6. So there's the answer, 6, -6, 3. You can plug, you can play the plug-in game on any of these where you're solving. Anytime your problem has an equal sign, You can just play plug-in on a multiple choice test, but you won't get credit for this problem without me seeing your process and following it. I'm going to look at it. You can't just put down crap and expect me to believe what you got. Okay, let's look at number 5. If you get stuck on one of these on your test, yes, this is, no, this is add eliminate, because we didn't get y equals on anything. So this is add eliminate. And I don't know that, I mean, you can certainly do what you want to on this one if it doesn't have instructions. And I just can't remember, but I think it does tell you by add elimination. The only other way that you've got to do one of these threes is matrices or Gaussian. Those are the same things. And we'll get to that. So it'll say, solve the system using matrices. If I want you to do the 3, -8, -2, go the 1, 1, 1 on the diagonal. So it'll say matrices. Yeah, I think you can distinguish that without any problems. Okay, so here's what we've got for number 5. And what I was thinking of is if you get stuck and you've got an answer like z equals 25 over -58, some mess that you know is wrong, I would not go back through your problem and try to find your error. That's really difficult to do on these. You can convince yourself, yeah, that's right, that's right, that's right. You just don't see an error when it's written there. So if you come across something like that, start fresh. Pick a different pair of equations. Do something like that. Start fresh. Okay, let's look. These are our 3 equations. We've already got a keeper equation right there. There's an equation in 2 variables. So take advantage of the fact that they've handed you half your work practically. Now, you got to notice this has got an x and a y, so they've killed the z's. So when you go and do this, you've got to kill the z's. And in this particular problem, that's going to be a very easy thing to do because the z's are prepared to die right there. Minus z plus c, gone. So we get 6x, 8y equals 24. And there's our other keeper equation. Okay. And now that's going to be lovely because these two already have, let me just bring them over here together. 6x plus 8y equals 24. You can kill the x's, no problem. Just multiply that times -1, either one of the equations by -1. So sometimes you end up with a pretty easy thing. We got 7y equals 0. So y equals 0. So we've got one of our variables, 0 there in the middle. Now, once you've got one good answer, you go back up to where the 2 variables, the 2 keeper equations, either of these 2 keeper equations is good for you. So I'll just grab this top one, 6x plus y is 0. So that goes away and we get x equals 4. Now you're armed with 2 of them and you can go up and grab any of the 3 equations. Well, you can't grab this one. It's only got an x and a y. That's not going to get you anywhere. You could plug that in and yeah, that's true. You got to plug it into once you have 2 answers, you have to go to where there are 3 variables. So good, I want to look at this first one to remind you of something that students tend to forget sometimes. So there's the problem. Let's plug in what we know. 4 plus 0 minus z equals 24. That leaves us with 4, so we're going to move the 4 over. So we get negative z equals 20. Watch out for that. Don't lose that negative. So z is a negative 20. Just be careful of that. When the variable has, when it's a 1 there, we tend to just kind of leave that negative off sometimes. Okay, that's number 5. Let me write down for you number 6 that I changed. If you grabbed the review early last week, last week, it wasn't perfected. Let's see, so number 6. Let's see, we have got $13 tickets, $26 tickets, and VIP tickets for $38. So those are the three levels. If 7 times as many $13 tickets were sold as VIP tickets, and the number of $13 tickets sold, and this is on the review that's on the Google slide, was 50 more than the sum of the number of $26 tickets and VIP tickets sold sales of all three were 37,460. How many tickets of each kind were sold? Okay, let's get a label. So we've got X will be the number of $13 tickets. Y will be the number of $26 tickets. And Z will be the number of $38 tickets, which are the VIP tickets. So these are the numbers of pieces of paper. Like if X tickets at the cheap seats are blue tickets, then this stands for the number of blue pieces of paper that were sold, number of yellow pieces of paper, number of VIP tickets, that kind of thing. Okay, we've got three variables. We need three sentences. If 7 times as many $13 tickets, so $13 tickets is X, were sold as VIP tickets. Okay, let's start out by saying they are equal. We're going to do this on this sentence and the next sentence. Let's start out by saying they're equal. They're not. They're telling you 7 times as many of these were sold. So this is not a balance. It's way heavier on this side. There's 7 times as many blue tickets sold as VIP tickets. So we're going to need to multiply that side, the light side, times 7 to make them equal to each other. So we started out with X equals Z. That's not true. 7 times as many of the cheap seats were sold as the VIP tickets. So in order to balance this is really heavy on the X side. You've got to help the Z side. You've got to multiply it times 7. That seems to me counter. I mean, I have to fight that all the time. The second equation will be similar to that. The number of $13 tickets sold, so that's X, let me put an X here, was, that's an equal sign, 50 more than the sum of blah, blah, blah. So 50 more than the sum of the number of $26 tickets and the VIP tickets. Okay, let me show you another way of thinking of this one. But you can just translate it. The number of $13 tickets, that's X, was, that's an equals, 50, there's 50, more than, that's a plus sign, the sum, so we're going to sum them, of the number of $26 tickets, Y, and the number of VIP tickets, Z. Another way of thinking of that one is the number of $13 tickets wasn't equal to Y plus Z. The number of $13 tickets was 50 more. So again, this is heavy, so we need to add 50 over here. I think it's easier to see this 7 one, and it's easier to just translate this one. So you might want to practice a little bit on this number 6 on your practice, and know that every problem is worth 4 points. So if this is just beyond your capabilities, even if you get the right answer, I won't give you credit unless I see some of this kind of stuff. So, you know, just decide. You've done 11 points worth of work on my math lab. If you don't feel like doing this, don't do it. I don't want you to do that. I mean, some of you, are going other places, so you need to make your brain work. But if you've had it, and if this is going to depress you, and it won't be number 6 on your test. Remember, yours are randomly generated on your test. But you do whatever you need to do to get through this test in a successful way. You're done. You've just got to put in the time and get out of this class successfully. You're there. So keep it up. Let's see. I still have some sections of my life okay if I finish. Yes, absolutely, Ashish. Yes, the due date is Thursday night at midnight, and then the review will stay open until Friday at midnight. I'm not going to close it and then reopen it. So absolutely, get in there and get them done. Get those points. Those are not free. I mean, you're not handed them. You have to work for them, but they're not under the kind of stress that a test is. So yes, absolutely. Okay, and we need a third. I did that just for you. Let's look at this last sentence. Sales. So now we're talking about money. Sales of all three was equal to that amount. So let's slap dollar amounts on each of these. So X, let's see, this is the X tickets, those are 13 each, plus the Y tickets, there's a 26 each. Each one of the yellow pieces of paper stands for $26. And then the VIP tickets, each one of them stands for $38. Money, money, money equals money. Okay, so we have these 3 sentences. So let's get them in order. X minus 7Z equals 0. Move that 7Z over. You got to get them in XYZ order. Let's see, we've got X here. The Y will move over and become a minus Y. The Z will move over and become a minus Z. 50 will be left on the left-hand side, on the right-hand side. And then this one looks good. Plus 26Y plus 38Z equals that great big number. Now, I have practiced this a few times and practiced different versions of this. I can tell you that it's easy to make a mistake if you are thinking about other things. So be careful on this one. Make sure you're focused on it. Let's see, we've got one keeper equation right here. Let's take advantage of that. I got to notice that I got rid of Y in that one. So when I go to do the second keeper equation using these 2, I've got to get rid of Y again. So I'm going to multiply this equation times 26. That will give me a negative 26Y, cancel out with the 26Y. And then 50 times 26, let's see, that'll be a 0, 30, carry the 3, 1,300. And that's the thing. Don't assume your brain can do it. Verify it. 50 times 26, 1,300, okay. Good, those will cancel out. Okay, those are gone. Let's see, we got 39X plus 12Z equals 0.6783, probably. Yeah, if that's wrong, somebody tell me. Okay, so there's our other keeper equation right there. Let's bring them together. X minus 7Z equals 0. 39X plus 12Z. Whoa. Okay, we could multiply both these times 7 and 12. We're not going to do that. We're going to multiply this one times a negative 39. So negative 39X. Now we need negative 39 times 7. 273, and that's a positive. And then negative 39 times 0. There'll be Z in there too. 273Z. Let's see, so we're going to get 285Z. So 38760 divided by 285, get 136. Remember, these are numbers of tickets. If you don't get a nice, pretty number, start over, do something different, come back to it later, whatever you want to do. Okay, there's Z equals 136. That's one of them. So we know we sold 136 VIP tickets. Go grab one of the keeper equations. I think I'll just grab this one. So I've got x minus 7 times 136 equals 0. So x, let's see, 136 times 7 is 952 equals 0. So x equals 952. That's x of the cheap seats, 952 of those. And then just grab one of the equations, one of the equations that have 3 variables. Top one doesn't have 3 variables. I'm going to grab this middle one. So x is 952 minus y, I don't know y yet, minus z is 136 equals 50. Combine like terms. 952 minus 136, that gives me negative y plus 816 equals 50. Subtract 816 from both sides. So that'll be a negative 766. So y equals 766. So there are 3 numbers of tickets sold there. Okay, yours is something like that, a little bit different from that. Okay, let's look at number 7. X plus y equals 2 and y equals x squared minus 7x plus 10. This problem on your test suggests substitution, and that is going to be by far the easiest way. There are 2 ways to do this, and by far substitution is the easier way. So let's substitute that block because it's already set up, y equals, plug it into there. So we've got x plus x squared minus 7x plus 10 at x plus, and then it said y, so we plugged in that whole quadratic, equals 2. Let's combine like terms. We've got an x and a negative 7x there. So getting them in order, x squared, this is a 1x, minus 7 will give us a negative 6x. Might as well move this 2 over, plus 8 equals 0. So get it all ready to factor. X and x signs need to be the same, and they need to be negative. What will multiply to give you 8 and add together to give you 6, 2 and 4. My guess is you've gotten to be a better factorer this semester. Okay, so we have 2 answers happening here. When x equals 2, let's figure out what y is. I'm going to use the easier of the 2 equations. So 2 plus y equals 2, so y equals 0. So when x is 2, y is 0. And then use the same equation. 4 plus y equals 2, so y equals negative 2. So the other answer is 4, negative 2. There's an answer, and there's an answer. You're expecting 2 answers. Those are the pairs of, that's the 2 sets of numbers that will work in both of these. And then to remind you, this problem is similar to it, solved by substitution, xy equals 6, and x squared plus y squared equals 37. Omit that problem when you get to it. I don't want you to get frustrated. You know, I could just not tell you that, but my worry is that you would get frustrated by it because we haven't done one like it. Many of you are capable of it, but we're not going to go over it because we didn't do it in class, blah, blah, blah. So just omit that one when you get to it. And if you forget and try it, I'll still give you credit, whatever. Okay, let's start doing some graphing here, graphing some inequalities. Number 9, x plus 4y is less than or equal to 12. You'll need to get that into y equals mx plus b in order to graph it. I am not going to check that. There are other ways of doing this without, so you do whatever you want to do on these. I'm not going to require you showing me your work on these. I'm not going to look and see. So 4y is less than or equal to negative x plus 12, and then divide everybody by 4. So we're going to get y is less than or equal to dividing by 4, dividing by 4, dividing by 4, plus 3. So there's that guy in y equals mx plus b form. The slope here is negative 1 over 4. The y-intercept is 3. So let's see. y-intercept is 3, somewhere up there. Go down 1 and over 4. And then all of that is old. Now you've got to decide if you're going to do a solid or a dashed line. It's got the solid line written there, so you get to put in a solid line. And then that is the barrier. That is the boundary between the good stuff and the bad stuff. One half plane is the correct answers, one is the wrong answers. You've got to figure out which one it is. This says less than, so you're going to always shade underneath when it's less than. You're trying to find where the y-axis has little numbers, where the little numbers are on the y-axis. So that's what you're looking for there. Solid line, shading below. Okay, number 10, y is greater than 2x minus 3, and y is less than x plus 3. Okay, they're both in y equals mx plus b. I think you said the same thing there twice. Let me see. Did you go over 4 or over 1? Okay, so this is rise over run. So I'm going down 1 from here, down. This is 3. So I'm going down 1 to about 2, and then over 4. So the top number tells you up or down, and the bottom number tells you sideways. So I went down 1. I went over 4. Well, I went not in any of those orders. I went down 1, and I see you said gotcha. Down 1 and over 4. Only because it's a negative. Okay, let's get these two done. This one right here, the slope is 2 over 1, and the y-intercept is negative 3. So let's see. Y-intercept is negative 3 down here at negative 3. And then I'm going to go up 2 and over 1 because this is positive. So up 2 will take me to a negative 1 and over 1, something like that. This is not a solid line, so I got to dash this guy. And then I'm going to shade where the y numbers are big. The y numbers are big up here on the thermometer, up top. Always greater than is above. And then let's look at this one. The slope here is 1 over 1. And the y-intercept is a positive 3. So let's go about right there to a positive 3. And then go up 1 over 1, something like that. Again, this is also a dashed line, something like that. Oh, it looks like I need to extend this little puppy here a little bit further, something like that. And then we're shading on this second line where the y numbers are little. Y numbers are always little down below. So I'm shading something like that. You will not have this mess on your test. You'll have only the answer. So the answer is where the two overlap. And that's in this little pie shape here. There's the answer. This part will not be shaded. This part will not be shaded. They'll only have between them shaded. The above of the first line, the below of the second line. Okay, now we get into the matrices. We're going to, anybody, Ashish, does anybody still need to look at this? Okay. Good, thank you for monitoring the situation. Okay, let's look at the augmented matrix here. Something like that. You're going to go 2, negative 1, 9, and then negative 6 over there. 4, negative 6, there is no z, so put a 0. And again, you're not writing these yourself, you're matching, and they will not have one where they don't put a 0. So you're not going to have to, oh, what if I forget? You won't forget, it'll be there for you. Okay, there's the augmented matrix, you're good. That's all they want you to do on one, so there's some free 4 points. All right, let's see, next, we're going to solve the system using matrices. It tells you to use matrices. That's the diagonal 1, 1, 1 line with the zeros down here in the lower left. You got to do it that way. You got to play that game. First thing I see is that, well, let's go ahead and write the augmented matrix. 3, negative 8, negative 2, negative 8. 2, 6, negative 5, 14. 1, -2, 0, and 2. First thing I'm seeing is that I've got a 1. Remember, you want a 1 in the upper left-hand corner? So let's get this guy up on top. So let me write that over here. So that puts the 1, -2, 0, 2 on top. Might as well not do work if you don't need to do work. Okay, so there it's written, just moving the bottom line up to the top. You know, remember, they're just 3 equations. We're just picking this one up, moving up to the top. Who cares? What if they'd given them to you in that order? It's not going to change the answers. So we've got a 1. Now what we want to do is make this a 0. That's a 2-step process. So we are going to bounce off of the 1. So -3 times row 1 plus row 2. Now when they do yours, they're going to put all of these instructions on the middle line. They center them on the middle line. I'm just doing that. And I hope that that does not lead to confusion for you as you take your test. You rewrite it if you want to, where you put them like we're used to, if that's what you need to do. Okay, so I'm going to move down here. So let's see, if I'm working with row 2, row 1 is not going to change. Row 3 is not going to change.
How did you know to do like the -1 for row 1?
You mean the -3?
I mean, yeah, the -3. Where did you get that?
You know that because when you're trying to turn something into a 0, that's a 2-step process. Let's start over. When you're trying to get a 1 generally, when you're trying to create a 1. Oh, hi, Kaylina. Good to see you in this class. That's a little change for you. When you're trying to create a 1 there, that's a 1-step process, and you're always going to multiply by the reciprocal. Now, we don't have one in this case. We just moved that line up, but we will be doing it to this number, so we'll get a chance to do that. When you're creating a 0, as we're doing right here by creating this 0, that's a 2-step process, and what you're going to do is the 1, your 1 line, multiply the 1 line by the opposite of the number you're trying to change to a 0, and then adding it to that, and then add. So we are going to multiply the 1 line times the opposite of what we're trying to change to a 0. So our goal is to make that guy a 0 right there. So we're always going to be bouncing off of the 1 line and multiplying the 1 times the opposite of the number we're trying to turn into a 0. So we'll do -3 times the 1, that gives us a -3, and then plus 3, bam, we've got a 0. And that gives us the 1 here, which we moved to get in place, but it gives us a 0 there. So we're on our way to ending up with 1, 0, 0, which is the first step. We're going to do it again right here in a minute. We're going to have to do the same multiplication, multiply this times -2, and then add in this line. But that's not this step. This step is just getting this guy to be a 0. Are you kind of okay with that?
I think I got it. So
Okay.
the second step was getting the 0. And the first one that we gotten a 1, press the opposite of the 3 in the second one.
Yes.
Okay, thank you.
And because we've done it to one of them, we've got to do it to the rest of the line. So -3, continue multiplying this top row times -3, and then adding in row 2. So -3 times -2 gives you +6. 6 and a -8 gives you a -2. Keep going. -3 times 0 is 0, plus -2. And then keep going. -3 times 2 is a -6. -6 and -8 give you a -14. Oh. Okay, let me come back in. I'll be right back. I've done this before, so that's hilarious. Okay, I'll be right back. Okay, hoping that that is better. Good. Yeah, and that happens in the afternoon class more than it happens in this class, I know, and I've popped in and out easily, and so it's an easily solvable problem. Okay, let's keep going. So we've got a 1 here, we've got a 0 here. Now we need to make this guy be a 0. So still, when we are creating a 0, that's a two-step process. We'll multiply this top line, or one line. We'll multiply it by the opposite of that number. So we're going to do -2 times row 1 and add it to row 3. So that -2 times 1 will give you a -2. Plus 2, that'll be a big fatty old good 0 right there. So once again, I got stuff out here. I didn't mean to do that, so I'm going to have to just do a sideways thing. Because I'm changing row 3, the other two lines will not change. And if you make a mistake in copying that, like if I don't see that negative right there, I'm screwed. This whole thing gets, blown up, so be really careful. So -2 times 1 is a -2, plus 2 gives us a 0, yay. -2 times -2 is 4, 4 and 6 give you 10. -2 times 0 is nothing. -2 times 2 is -4. -4 plus 14 will give us 10. Okay, so we've got 1, 0, 0. Now we want to work on this 1, making this guy a 1. Whenever you're trying to create a 1 in that diagonal line, that's a one-step process to create a 1, multiplied by the reciprocal. So we're going to multiply by the reciprocal of this guy, and that's a -1/2. So we're going to multiply -1/2 times row 2. It's just one step. Notice these others creating zeros were 2 steps. This is just one step. And if you are only changing row 2, row 1 stays the same, row 3 stays the same. So -1/2 times -2 gives you a 1. Yay, that's exactly what we want to have happen. -1/2 times -2 gives you a 1 there. And then -14 times -1/2 gives you a 7 there. Okay, we've got a 1 right here. Now we want a 0 underneath. We've got 1, 0, 0. We're working on our 1 diagonal. We've gotten that done. Now we want this to become a 0. Whenever you're creating a 0, that's a two-step process. You multiply the 1 line. So we're going to multiply this line, the second line where our 1 is, by the opposite of that number. So -10 times row 2 plus row 3 will create a 0 there. Because we're affecting row 3, the other two lines will not be affected. And now let's do -10 times 0 is 0 plus 0. The ones we've changed already will never change again. -10 times 1 is -10 plus 10. Yay, we've got 1, 0, 0, 1, 0. We're there. We're almost there. -10 times 1 is -10 plus a -5 gives you -15. And then -70 plus 1 gives you -60. Okay, almost there. We've got 1, 0, 0, got 1, 0. All we need to do is create this to make this be a 1. The way to create a 1, that's a one-step process, multiply by the reciprocal. So -1/15 times row 3. I remember Chloe asking about that, about the negativeness of it. And that was helpful to not just her, but to a lot of people, I'm sure. If you're doing the reciprocals have the same sign. If you've got a negative on the number and you're trying to come up with the reciprocal, it'll also have a negative on it. Okay, let's get this done. So row 3 is changing. So row 1 is not, row 2 is not, but row 3 will, but not the two zeros we already have in place. -1/15 times -15 is a 1. You can check in your calculator. Negative times a negative is a positive. We've got the rows of 1, so we're done here. -1/15 times 60 will give us a +4. There, now that we've got this, we've done the Gaussian work, now we're going to use back substitution. Let's look at what this says. This says x minus 2y equals 2. This says y plus z equals 7. We're translating back from the augmented matrix into the variables. And it says z equals 4. Well, there's one of our answers. So these three equations will cross at something, something 4. Now work your way back up. That's why it's called back elimination. We're going to go next. We're going to plug that 4 in right there. So we get y plus 4 equals 7. So y equals 3. There's our second number. And then we will take these two and plug them in here. We don't need the z. This equation didn't have a z. That's okay. X minus 2 times y equals 2. So x minus 6 equals 2. So x equals 8. So there we go. There's our answer, 834. Okay. If you need a little more work on that, go back to the section where we did that and look at the video from it. Let's see. That is section 6.1, 6.2. That's where this one comes from. 6.1, 6.2. Go back and follow those steps because, you know, I took a little bit more time explaining it in those. All right, let's look at what we're going to do here. We've got two matrices, and we're going to do A plus B. Let's just do A plus B right here. This is A right here. This is B right here. You're just going to add corresponding parts. Negative 10 plus 4 gives you negative 6. 3 plus 11 gives you 14. 14 and negative 8. Negative 7, negative 10, and then just, you know, complete it. That's A plus B, easy enough right there. Let's do A minus B. Be careful on A minus B. In order to do A minus B, you have to be sure you've got A first. We do. And then we're going to do minus B. Put a minus in there. So A minus B, that's negative 10 minus 4, that's negative 14. 3 minus 11, 14 minus negative 8 is 22, negative 7 minus negative 10 is 3, and if your brain isn't great at doing that as fast as mine, that's okay. You've got a long time to take your test, and you can use a calculator. Negative 15 minus 20, and then 5 minus 1, so we end up with that answer for A minus B. 10A is just multiply each of these times 10. So let's squish that in there. 10A, you're just going to multiply negative 10 times 10, so negative 100. Stick a 0 on the back of these is basically what you're doing. Times 10 each time, times 10. So we end up with that for the 10A. And then 2A minus 10B, that's going to be a little more involved. So let's see what we can do here. This is number 13. A is that. B is that. And we are doing 2A minus 10B. So I'm going to do 2A, just double each of these. There's 2A, just multiplying each of those terms times 2. I'll subtract in a minute. Right now I'm going to multiply each of these terms times 10. 210. And then 2A minus 10B, negative 20 minus 40, 6 minus 110, 28 minus negative 80, it looks like that'd be 108, negative 14 minus 100, 86, negative 30 minus 200, negative 230, and then 10 minus 10. I think that's right. That was kind of quick and sloppy and like it didn't matter. I think that's right, though. Okay, so that's number 13. Number 14, 3x plus a equals b. It says solve it for x. So I'm going to get x by itself. This is 3x plus a equals b. I want to solve for x. So I want to get this little guy by himself. There are lots of ways of doing this, but I've just discovered over the years it's just easier to first isolate x. Let's move a over. 3x equals b minus a. Be real careful of that. B is positive, a is negative. You could have negative a plus b there, just as long as you make sure a has a negative on it. And then we'll divide by 3. So x is going to equal b minus a over 3. Okay, I discovered in preparing for today that I can actually go backwards. 4 minus 10 is negative 6. Negative 6 divided by 3 is negative 2. But that's not a safe way to do that. If I were doing it for a test, I'd write it out. I would not do it in my head backwards. So let me show you how I would advise you to do that. We want b minus a, and then we'll divide it by 3. So let's get b here. B is 4, 5, 6, negative 4, 5, 6. I'm putting b first because it comes first. 10, 5, 0, negative 5, 11, negative 6. Okay, so if I'm doing b minus a here, 4 minus 10 is negative 6. 5 minus 5, 6 minus 0, negative 4 minus negative 5 is 1. Yeah. 5 minus 11, and 6 minus negative 6. Okay. So I would advise you to put them in the correct order rather than trying to subtract going backwards. And then remember our x was b minus a divided by 3. So we're going to take each one of these and divide by 3. So that's a whole number. That's a whole number. That's a whole number. This is not, so you would expect to see a fraction. Negative 6 divided by 3 is a whole number, and 12 divided by 3 is a whole number. So use fractions, not decimals. Let's see. On my notes, I have asked you to find, on B, on this one, I've asked you to find A sub 2, 3 on this, for this matrix. It's not part of the number 13 at all. It's just I added it in there because you will have a problem like that on your test. So for this matrix, find the element that's in the position of 2, 3. You have to know that that means the second row, third column. So second row, remember rows are like rows in the movie theater. Columns are like architecture. So the second row would be this middle row. And the third column, we don't have a third column. So there is no answer for that. There is none. If it had been find the element in the 3, 2 position, that would be the third row, second column, that would be this guy right here, would equal 1. But we don't have an element in the second row, third column, because we don't have a third column. Okay. Let's see. Let's look at number 15. If possible, find AB, and then we'll find BA. We're going to find both of them if we can. Let's see, AB. Remember, you've got to look at the order of these. This is a 1, 2, 3 row, 2 column. So A is a 3 by 2. B is 2 rows by 3 columns. In order to multiply them, those numbers have to be the same, and they are. And our resulting matrix will be a 3 by 3. So on number 15, let's see, let me write these down. We've got 7, negative 1, 0, 2. There's A. There's B. And our resulting matrix, our answer will be a 3 by 3. And I just think it is the thing to do to put them in, to scribble yourself answer blanks there so you know where you're going. Okay, we are looking for the one that is in the position of row 1, column 1. So we are going to use row 1 from A and column 1 from B. So row 1 is this, 7, -1. Column 1 is 0, -4. So multiply the firsties. 0 times 7 is 0. And then scoot over on the row, because this is the one we're looking at the row. Scoot down on the column. -1 times -4 is a +4. So that'll be a 4 and will never change. Next thing we're looking, you can look for any of these. The order does not matter, but I'm just going to go across. So this is row 1. This is column 2. So I'm going to use row 1 from A and column 2 from B. This is B. So row 1 is the 7, -1. Column 2 is the 1, -1. So 7 times 1 is 7. -1 times -1 is 1. So 7 plus 1 is 8. That goes there. This guy's position is row 1, column 3. So I'm going to use row 1 from A and column 3 from B. Row 1 is right here. Column 3 is right here. So start at their beginnings, the left-hand side and the top. 7 times 2 is 14. Scoot. -1 times 1 is -1. So 14 minus 1 gives you a 13. So we're done with that. And I know that some of you might have this down cold, but others of you might not. So I'm just going to go through the whole process here. So when we're doing this position right here, this is row 2, and it's column 1. So I'm going to use this guy's row 2, this guy's column 1. 0 times 0 is 0. 2 times -4 is -8. This one's position, he's in the second row, and he's in the second column. So we want to attack the second row of A, the second column of B. 0 times 1 is 0. Scoot. 2 times -1 is -2. Now let's go after this position. Row 2, column 3. So I'm going to do row 2, that's the 0, 2, and I'm going to use the 2, 1. 0, 0 is your friend. 2 times 1. And then finally, row 3, column 1. That'll be row 3, the bottom row, the column 1, because that position is in row 3, 1, 2, 3, column 1. So row 3 is here, column 1 is here, 0 and 0. This is row 3, column 2. So row 3, column 2, -3 plus 0. And then finally, row 3, column 3. So we're using row 3 and column 3, -6 and 0. Okay, so this is AB. Next thing they asked us for is to do BA. BA, let's look at that. B, we already know, is a 2 times 3. A is a 3 times 2. We can only do BA if those match. They do. And then we know that our remaining matrix, our answer matrix, will be a 2 by 2. So we put them in the right order. B is 0, 1, 2, -4, -1, 1. There's B. And A is 7, -1, 0, 2. There's A. We're trying to do BA over here. So BA is going to be a 2 by 2 matrix. 2 rows, 2 columns. So this position is in row 1, column 1. So we're going to use row 1 from there, column 1 from here. Row 1 is here, column 1 is here. So start on the left, start at the top, and multiply all the way through. It's 3 products you'll be adding. 0 times 7 is 0, 1 times 0 is 0, 2 times -3. There we go. Next, we're doing row 1, column 2. So we're going to multiply row 1 times column 2. So 0, 2, and 0. Next, we're doing row 2. This position right here is in row 2, column 1. Sorry, row 2, column 1. So multiply row 2 times column 1. Negative 28, 0, negative 3. So negative 31. That's negative 28 and negative 3. And then finally, this guy is in row 2, column 2. So I'm going to use row 2 and column 2. 4, positive 4, minus 2 is 2 and 0. So there we go. There's BA. Okay. You'll only have one of those, even though there are 2 practices here. That's good. Okay, let's use Cramer's rule to solve the system. Let's see. We need a whole bunch of information. I think it'd be easier to do it here. Number 16, 2x plus y equals 8, 7x minus 3y equals 2. This would be super simple if you did substitution, y equals 8 minus 2x, or if you did add eliminate, you could just multiply the top row times 3. But the instructions will say use Cramer's rule, and so you have to use Cramer's rule. I will go after and see that you did. If you didn't, you don't get credit for it. I know you can get the answer. I want to see if you know what Cramer's rule is. So we need the big determinant here. The big determinant is made of the x's and y's numbers, 2, 1, 7, negative 3. It's going to give us negative 6 minus 7, that's negative 13. So the main determinant is negative 13. Then we need a determinant for x, d sub x. That's going to be the same determinant, this 2, 1, 7, negative 3, except that if we're looking for x's answers, we put the answer in the x column, and we use the y's, the y numbers. Instead of this 2, 7, we put the answers in there. Gives us negative 24 minus 2, that's negative 26 for d sub x. D sub y is the same exact thing. We're looking for the y answer, so we're going to base it off of this, leave the x's alone, change the y's to the answer, to the 8, 2 column. And then we've got 4 minus 56, and that gives us a negative 52. Okay, to determine the answer, x equals d sub x over d, y equals d sub y over d. Who had time to sit around and do all this, you know? Who came up with this? Good thing nobody put me in charge of coming up with this, because we'd still be not using Cramer's rule. That equals 2. Down here, d sub y is negative 52 over negative 13, and that's 4. So the answer is 2, 4. Okay. Number 17 is asking you to write the first 4 terms of the sequence with this rule. So here's the rule, a sub n equals 11 to the nth power. So a sub 1 equals 11 to the nth power. This is the first power, so that's 11. A sub 2 says go over here, and when you see an n, substitute a 2. When you see an n, substitute the n. It's the third term. And then the fourth term, put the 4 there, and 14, 6, 4, 1. Okay, that's just going to be plug in on the ends. No big deal there. Number 18. This is a recursive formula. What are the first 4 terms? They give you the first one, and then you can see the formula is based off of an n minus 1 for n is greater than or equal to 2. N doesn't need to be 1 because you've been given that. So I'm going to give that information here is 13, and then a sub n equals a sub n minus 1, which is always the previous one, plus 8. So it asks you for the first 4 terms. We've got a sub 1. Let's do a sub 2. Let's put a 2 in here. That's a sub 2 minus 1 plus 8. That's a 1. And a sub 1 is just the previous answer. So we get a 22 there, 21 there. A sub 3, again, put in a 3 right there. So that's 3 minus 1 plus 8. That's a 2. And a sub 2 is just the previous answer. 21 plus 8 equals 29. A sub 4 is a sub 4 minus 1 plus 8. That's a 3. That's always going to be the previous answer. And we get 37 out of that. So the first four terms are 13, 21, 29, and 37. And I'll see that you use this correct. So I want to see that you didn't just figure out which one's right or get lucky or whatever. I want to see your work there. Number 19 is using summation notation. Tells you k equals 1, goes all the way up to 6, and 3k to the 4th power is the math that you're doing on each one of these. So we're going to start where the variable is a 1. So k equals 1 all the way up to 6. 2, 3, 4, 5, and 6, all the way across there from 1 to 6. Then what we're going to do is use this formula. So if I put a 1 in there, k to the 1st is just, or sorry, 1 to the 4th power. Put the k, put 1 in for the k. 1 to the 4th is 1. So 1 times 3 is 3. Next time around, put in a 2 for k. 2 to the 4th, that's 2, 4, 8, 16. And 16 times 3 is 48. Next time, k is 3. 3 to the 4th, that's 3, 9, 27, 81. And 81 times 3 is 243. Next time around, k is a 4, so we're doing 4 to the 4th power. 4 to the 4th power equals 256, and then times 3, so we're getting 768. Then plug in a 5. 5 to the 4th power equals 625, times 3 is 1875. And then 6. 6 to the 4th power is 1296, times 3 is 3888. Okay? This sigma, Greek symbol, says to add all these together. So number 19, I would have taken as much time just to do it. 6825. 6825 is the answer. So that's the answer, and I would expect to see something like this. It doesn't have to be horizontally, you can do yours vertically, whatever, but I want to see each of your terms there. The way that you do it otherwise. Yes, ma'am.
So if the k was a different number, like 3, for instance, would it be, okay.
You would start at 3 and go to 6.
Okay, I just want to make sure I got that right. Thank you.
You got that right. Did you email me about that this past week somewhere?
Yes, I
Is
did.
that you? Yeah, okay, so yes, whatever number it tells you there, that's where you would start your set of numbers.
Thank
Your
you.
mic is buzzing from the beginning.
What, Kaylina?
Your mic
Oh,
is still
okay.
buzzing from the beginning.
Okay, see you. How about now? Good. Okay. Just about the time I get pretty decent at this whole thing, we go back face to face. Okay, let's look at number 20. Find the first 6 terms with this detail. Okay, of the arithmetic sequence. It says it's arithmetic sequence, so you know that that is a sub n equals a sub 1 plus n minus 1 times d. That's a formula you're going to have to memorize. They tell you that a sub 1 is 390, and the common difference, what you're going to subtract each time, is 110. So a sub 1 equals 390, that's given to you. The common difference is 110, is negative 110. So we're going to subtract, and you can get 280 there. A sub 3, subtract another 110, 170. A sub 4, subtract another 110, I'm not going to check your work here because I know we have so few, you can just do it. So I will not check your work. You don't have to plug it into here. So on this particular one, you would not have to show the formula. I will not check your work here. I'm just looking for the series of numbers. Number 21 is a little different though. It's asking you to find a sub 80 with this information. So you're going to need to simplify the formula and find a sub 80. So let's do that. Let's look at a sub n equals a sub 1 plus n minus 1 times d. And in this case, a sub n equals a sub 1 they told you was 33 times n minus 1 times negative 6. They told you the common difference was negative 6. You need to distribute it. 33 minus 6n plus 6. Add the common terms. That gives you 39 minus 6n. There's the formula. There's what they're looking for when they say simplify the formula. They're looking for that. Then you're asked to find a sub 80. So 39 minus 6 times n is 80. It didn't say n minus 1. That's gotten scarfed up here. So let's continue. 39 minus 480. So that is a negative 431 right there. So those two answers. You'd have to show the formula in order to simplify it. I won't accept it. Did you just guess right or whatever? So got to see it. Let's look at number 22. Find the first 5 terms of the geometric sequence. Okay, again, oh, and then you're asked to use the formula. So you will need to know the formula here. So a sub n equals a sub 1. It's just like the previous formula, but then times r to the n minus 1. So if we're looking for the first 4 terms, a sub 1 they told you was 2. A sub 2, this is a common ratio you're multiplying. Times 4 will give you 8. Times 4 will give you 32. Times 4 will give you 128. And times 4 will give you 512, of course. So I'm not too bent out of shape about those numbers. I am bent out of shape that you can show me the formula for this. A sub 1 is 2 times the ratio, which I should have put a 4 in here, the n minus 1 here. 15 equals 2 times 4 to the 14th, to the 15 minus 1. You can write 15 minus 1, and I know you can do 14 in your head. So we're doing, remember your calculator can handle this. 2 times 4, it's not helpful to you. There we go. 2 times 4 raised to the 14th, and that gives you that mess. 5368, 70912. Okay, 536 million. Okay, we've got 3 other problems here that got added at the last minute. Let's see, number 23 is finding the determinant. -5, -3, 2, -7. I know you have to do determinant in Cramer's rule, but I also wanted to give you a separate problem for determinant. So it'll be -5 times -7 is 35 minus -6. So we get a 41 for that. Number 24 is just determine the order here of 7, 8, -1. What is that size? And so that size is how many rows, 1 row by how many columns. So this is a 1 by 3 matrix. And then if you're asked to find a sub 1, 3, that means first row, 3rd column. So it'd be a -1 right there. And then this final one, graphing, x is less than or equal to 2, here we go, and y is greater than -5. Okay, I'll give you one like this. So you got to find on the x-axis, find the 2, that's right there, there's 2. This will be a solid line, and we're going to graph everything where x is small. X-axis is the number line. You know where the small numbers are. The second one, on the y-axis, find -5. Let's see right there. This is going to be a dashed line. And you're going to shade everything where the y's are big. That's always going to be above. So the answer is this mess in here, right in here. It's where they overlap. That's the answer. The upper left-hand corner will be shaded. Okay, that is it. That's not too bad, 1 minute late, and I've got attendance, so I'm good there. I'm going to stop the recording.